All right, I just noticed that this says flipped 2.7, but it's actually 2.6. This was an introduction into proofs, basically. So I wanted to go over the problems you guys completed. Number one was straight out of your notes. I just want to make sure that you understand the concept of how we would make the proof for the vertical angles theorem. The concept here is if both 3 and 4 add to be 180 and 4 and 5 add to be 180, then 3 plus 4 must equal 4 plus 5, and you could do some subtraction. We'll look at the whole proof right here though. So first off, number one is angle 3 and angle 5 are going to be vertical angles. That's the given that you're going to put down. Next, we look at 3 and 4 and we look at 4 and 5, and they're both supplementary. And the reason why is because linear pairs are supplementary. Two angles that come together to make a line must be supplementary. Now that we have that, we're going to say that 3 plus 4, the measures of those angles equal 180, and 4 plus 5, the measures add to be 180. That's because of the definition of supplementary. The whole reason we're doing this is because we have two things that equal 180. We can set them equal to one another. So you end up with 3 plus 4, and those are supposed to say measure. I forgot to put that in there, but just make sure you understand that shouldn't just say angle 3 and angle 4. It should say measure of angle 3 plus measure of angle 4 equals measure of angle 4 plus measure of angle 5. Because you don't really add angles together, you add their measures. And why we did that is because of substitution. The reason we set it up that way is because you have a 4 on both sides. And you could subtract away the 4 on one side and subtract away the 4 on the other side, and you're left with exactly what we wanted, 3 being equal to 5. And then since we want to get exactly what they're asking for, and they want to show that 3 is congruent to 5, we just go, after you do the subtraction property of equality, we just say definition of congruence. Means if they're equal, then they're congruent. If they're congruent, then they're equal. So hopefully that made sense. If when we set this up, it was, let's say, the step right at 3, if it said 3 plus 5 equals 180, and let's say 7 plus 8 equals 180 or something like that, if you went over and set them equal to one another and you weren't able to cancel something out on both sides, then that would have been kind of a dead end. The only reason we wanted to set them equal to one another is because you could subtract the 4 from the left and also subtract it from the right. Now on this next one, we're trying to piece together the different tools that we've learned to prove that two angles are congruent. And basically, you're trying to come up with a logical path of logical reasoning that'll connect two different angles. So usually what it is you'll be given something. It's either a given or something that you already know, like the vertical angle theorem, which is kind of a standalone thing, or it's things being put together. So for example, on the first one, it says 1 is congruent to 2. That is not a given. If you look next to the given, that's 2 is congruent to 3. So we actually look at the diagram, and you see 1 and 2 are vertical angles. So that's a standalone thing. You just say VAT, vertical angles theorem. The next one was the given. Sometimes you have multiple givens, and you have to know which one goes where. But here, the only given is 2 is congruent to 3. So I put that in there. Now I forgot, or I don't have the little squiggly mark here, and that's just because I don't have my writing utensils so that I could write on the document, so I just had to put an equal sign. But that's supposed to be 2 is congruent to 3. Now the next one says 1 is congruent to 3. You look, it's not a given. And when you look at 1 and 3, they are not like vertical angles. It's not like a standalone thing. So the other option is it must have to do with things happening above in the proof being pieced together. So you say 1 is to 2, 2 is to 3, so 1 is to 3. That's a train of thought, so we call that the transitive property. Or you can think of it as erasing the 2 and putting what 2 equals, which is 3. So 1 being congruent to 3 in this case could be the transitive property or substitution. The next one says 3 is congruent to 4. Look, it's not the given. And when you look at your diagram, 3 and 4 are vertical angles. So it is a standalone reason. So 3 is congruent to 4 because of the vertical angle theorem. And then the last one, it says 1 is congruent to 4. It's not a given. That's not listed under givens. Don't write the word prove. It's not like, oh, where we put 2 is congruent to 3, put given, and since 1 is congruent to 4, let's just write the word prove. That's not how it works. Since 1 and 4 are not like vertical angles, it must be pieces of the proof above being put together. So 1 is to 3, 3 is to 4. So that means 1's now connected to 4 by a train of thought. So you could say the transitive property, or you can think of this as erasing the 3 here and putting in what 3 equals, which is 4. So that could be substitution as well. Now, technically, you could have said 1 is to 2, 2 is to 3, 3 is to 4, and then 1 is to 4, but that would have to be the transitive property because it's too long of a train of thought to call it substitution. It's either two substitutions or a single transitive property. Now, when we're looking at this one, it says 1 and 2 are right. That's the given. That's the only given we had there. Actually, we had two givens. You had to know which one made sense. Since the next one the second step had to do with right angles, it only made sense for the first part of your proof to have to do with the right angles. You had two options, 1 and 2 are right, or angle 2 is congruent to angle 3. The one that made sense to go first would be the thing about the right. So 1 and 2 are right, given. Therefore, 1 is congruent to 2 because all right angles are congruent. Next, we have 2 is congruent to 3, which is the other given. It's listed under the given. And next, 1 is congruent to 3. Why is that? Well, 1 is to 2 and 2 is to 3, so 1 is connected to 3. A train of thought, transitive property. Or you can think about erasing the 2 and putting in a 3. So that could be substitution. The last part of this homework was the congruent complements theorem says two angles that are complementary to the same angle must be congruent. And the congruent supplements theorem says two angles supplementary to the same angle must be congruent. And here's an example. You can see 1 and 2 make 90 degrees and 2 and 3 make 90 degrees. So 1 must be congruent to angle 3. Since they're both congruent to the same, or they're both complementary to the same angle, they're both complementary to angle 2, then they must be congruent. Same deal here. 1 and 2 are supplementary, 2 and 3 are supplementary, and since 1 and 3 are both supplementary to that same angle, they must be congruent. So hopefully that made sense. Proofs can be a little tricky until you get the hang of them. You can ask me questions when I'm back. Thanks, bye.